Good day, everyone. I'm Kushali Devendra Kumar. My metric number is B08211017 from Group 11. Our assignment title is DC to DC Chunk Converter, which is input 18 voltage and output will be 12 volt. I will explain about abstract part of this assignment. This electronic document is discussing the operation of a DC to DC converter which steps down the voltage input from 18 voltage to 12 voltage. A chunk converter can be seen as a combination of boost converter and a buck converter having one switching device and a mutual capacitor to couple the energy. The operation mode 1 and operation mode 2 of the chunk converter are stimulated by using MATLAB software. Keywords of this assignment is DC to DC converter, chunk, model 1, model 2 and MATLAB.
Good greetings to everyone. I am Kausalya Tyagu. B0821100351 is my matrix name. Now I am going to explain the introduction part of the DC to DC Cuk converter 18 volt to 12 volt. The DC to DC Cuk converter is named after its inventor Slobodan Cuk. This DC to DC converter has a fixed input and controlled regulated output. The converter can be designed flexibly and either step up or step down the voltage. This Cuk converter is a combination of the buck to boost converter which has reversed polarity. Traditionally, DC to DC converter buck, boost and buck to boost converters have one capacitor, one inductor, one diode and one semiconductor switch. But the Cuk converter consists of two inductors, two capacitors, two diodes and two semiconductor switches. The Cuk converter topology has a great advantage such that the voltage ripple is less at the input and output side. When compared to buck boost and buck to boost converters, the component count of the Cuk converter is higher, which is using two inductors, two capacitors, a diode and a switch make up the Cuk converter, with the input side resembling a boost converter and the output side resembling a buck converter connected by a capacitor. The Cuk converter produces a voltage that is opposite the input voltage. Thank you.
My name is Amy Sufia, and I would like to do a presentation of methodology for DC-DC converter for Cuk. Okay, so for the theory operation, the buck converter, buck boost converter, Cuk converter, and split converter are known as selected DC-DC converters. Using only a step-down converter called a buck converter, a fixed DC input could be converted into a dynamic, regulated, and controlled DC. Okay, so the buck converter is referred to a step-down converter since its output voltage is less than input value. The input current of a buck converter is increased by stepping down the input voltage, and the output current ripple is increased. Buck converter has less ripple in the output current. Okay, in a similar way, a boost converter increases input voltage while decreasing input current. The boost converter has a lower input current ripple, but the boost converter has the larger output current ripple. Due to the limits of buck boost converter, the combination of buck boost converter is favored for application with varying input and voltage level requirements. Okay, so depending on the duration, the buck booster converter steps up or steps down the input voltage level in the same architecture. A buck boost converter delivers to step up and step down of input voltage inside the same architecture with the same component count. Buck boost converter's output is inverted, but the topology output current ripple is still sizable. The capacitor input current and charge current are irregular, which sends cause EMI problems. Cuk converter was created to fix these issues. Okay, comparing the Cuk converter to the buck boost and buck boost converter, the Cuk converter has a higher component count: two inductors, two capacitors, one diode, and one switch to make up the Cuk converter. Okay, so as shown in figure 1, a Cuk converter combines a buck boost buck and boost converter so that the input side resembles a boost converter and the output side resembles a buck converter in an isolated investing way. The Cuk converter produces an output voltage that is opposite of the input voltage. So this is the figure 1. Okay, so for the theory operation of Cuk converter, as shown in figure 1, we have L1, L2, C1, and C2. In the inverters have a total 6 of components that do not carry any charge. The Cuk converter works for 4 cases to put it simply. Okay, for the case 1 is when the switch is on. Okay, so when the switch is on, ideally the power supply will charge the inductor when the switch is turned on, causing current to flow from L1, the switch, and then back to the power source because the capacitor and inductor don't have any current flowing through them. L1 is an inductor that charges up and has a positive negative polarity that makes it storage element. Technically, a small amount of voltage will be present in C1 that has been stored. The load is not receiving any current. Okay, for case 2, when the switch is turned off, okay, this is the figure for the case 2. The inductor L1 discharges the stored energy by reversing polarity when the switch is switched off. Current will flow from the source to inductor L1 together with the stored energy dissipating from L1 because the current flowing from inductor L1 is not entirely DC. There is a current flow within the inductor. Okay, so for the case 3 is when the switch is turned on. Okay, so when the switch turned on, the inductor charge up L1 and current flows from the source L1, C2 and the load. The voltage holding capacitor, however, has now discharged its energy. The voltage held by the load C1 and C2 and capacitors. In this procedure where diode D is reverse biased, the inductor L2 is additional charge. Okay, for the last case is case 4 when the switch is turned off. So this is the figure for case 4. In which capacity C1 lost its energy is repeated when the switch is switched off. Additionally, the capacity C1 inductor L2 discharged the stored energy to the load along with inductor L2, which was charged in instant C. Okay, the output voltage is reversible and the diode forward bias and the energy is dissipated capacitor C2 and L2. We obtain a reverse polarity at the output when compared to the input side voltage because the architecture of the on-off mechanism. Okay, so this is figure A. So figure 6A for mode 1 and figure 6A for mode 2. Okay, the Cuk topology in figure 6 resembles a buck boost converter in that it has reverse output voltage polarity and the ability to step the input voltage up and down. Comparing the Cuk converter to the 3 converters previously discussed, an additional inductor capacitor are present. When the MOSFET is in mode 1, okay, and this is mode 1, okay, um, the input voltage charge and inductor Li, and because the positive terminal of the capacitor Ci is grounded, the diode is reverse biased, making it look as though there is an open circuit. The inductor Li tries to keep the current flowing to the load by energy, releasing energy when the MOSFET is turned off during mode 2 figure 6. When the diode is activated, the inductor's currents Li and La flow through the diode. Okay, a closed loop system power stage is nonlinear system since nonlinear systems are changing the model to model and predict. It is common practice to the approximate nonlinear system to linear system. For the DC-DC converters, linearized power stage, the board plot can be used to choose the best adjustment in the feedback for the intended transition state response. In this instance, the state space averaging technique is used. Okay, so this is the operating during switch on. Okay, so this is the equation which is Give average description of the circuit of period of produce a moment by averaging the equation related to the state above. Okay, that's all. Thank you.
Assalamualaikum. My name is Nurul Jati binti Razura and my check number is 0821104110. For the conclusion, in this project, students can learn that the Cuk converter is a specific type of a buck boost converter with a low output ripple current with one switching device. A dual capacitor to couple the energy. This converter could be viewed as a combination of boost converter and buck converter. It offers an output voltage that is simultaneously greater than the lower input voltage. The output voltage value will be lower because of the. In addition, the element of average modeling of DC-DC converter that Cuk converter operates in both these continuous conduction modes. All equations in the development of the converter will consider the series the system of the capacitor, inductor, for the state space technique, the converter active element as well. The type of models that a Q converter could be represented as a state space switch or a PWM switch. Lastly, the result from the experiment and the simulation were presented to prove the efficiency of the purpose design. For the acknowledgement, we would like to thank to all of our people who helped us in this project. Without their support and guidance, it would not have been possible. We appreciate Dr. Hafiz bin Sakawi for the guidance and supervision, which has provided a lot of resources needed in completing our project. Our parents as well as friends will constantly encourage us throughout the process when we felt discouraged or become frustrated because they knew how much work went to the center so that is why we want to extend them thanks to. We are grateful for our colleagues in developing this project for their witness and assistance. They helped us with this project. We appreciate you. Thank you. That's all from us.
Assalamualaikum warahmatullahi wabarakatuh. My name is Gloriana Fatimah Amalia from Group 11. So, I want to explain about the result for DC-DC Cuk Converter. So, before we go to the simulation, I will explain about the calculation. First, step 1, we are given the parameter input equals to 11 volt and output 12 volt. So I assume frequency equals to 10 kHz, power equals to 20 watt, RO and RC1 is 1%. Then we calculate for the duty ratio. For the duty ratio, we get 0.4. And then for the inductance current, inductance currents 1 and 2, and then we search for the rate of change inductor current, and we get this result is 0.222, and for the rate of change inductor current 2 is 0.333, and then we can get the rate of change capacitor voltage, which is 0.3. After we get all the all of this, uh, we can go to find value for inductor 1 and 2. So for inductor 1, we get value is 3.24 milli, and for the second inductor is 2.16 milli. And then for capacitance, we get the value is 34.7 milli. But then we use 35 because it is near to 35. Last is the RL and C1. RL we get 3.6 ohm, and for the capacitance we get 444 milli. So this is the simulation. Okay. Simulation. This is for the inductor 1, capacitor 1, inductor 2, and capacitor 2. And then we put the RL here, and we put the current measurement here and the voltage measurement here. So the result we get 1.877, which is 10.877, which is near to 12 volt. And then this is the result. From the result here, if we adjust, we can get like this. And then for the discussion, from the simulation, we get output only 2 waveform. We get one for voltage measurement and current measurement. And they're just a bit different. And another method that we can use is using MATLAB coding, and this is the calculation. Okay, that's all from me. Another will explain by another member group. Thank you.